Howdy, here we go. We're going to talk about conjugates and radicals. We're going to use what we learned about square roots, cube roots, fourth roots, and now we're going to put that with conjugates. This first part, I just want you to watch. Do not take notes over this. Conjugates. Where have we seen the word conjugates before? Well, that's when I talked about complex conjugates, and I had 3 plus 2i times 3 minus 2i. I multiplied these out by foiling. My first was 9. My outer was negative 6i. My inner was positive 6i. That's a 6. Let's get an actual 6 plus 6i. And last was negative 4i squared. Whenever I did complex conjugates, my middle terms canceled out. So I had 9 minus 4i squared. We then remembered that I was equal to the square root of negative 1. So I squared was equal to negative 1. So here I have negative 4 times a negative 1. So that's a positive 4. So 9 plus 4 was 13. Whenever I multiplied by a complex conjugate, I ended up with a whole number or an integer, a positive or negative whole number. Today, what we're going to use this idea of conjugates with the idea that we just learned on radicals. And let's talk about how that would be used. So on the next page, this is the last example I'm going to do today. The question is this. Whenever we've worked with radicals, square roots, we've always said we don't want a root in my denominator. And say I always would multiply by, square root 5 over square root 5. The problem is when I multiply this square root 5 to this 2 over here, because I have to distribute it through, I'm going to have a square root 5. It doesn't clear it out of my denominator. So the question is, what am I going to do that? So I'm going to hit a series of examples to get us to that point. So let's go to example 1. Conjugates and radicals, simplifying. The first part of this, we're just going to do one of these. The first part of this is just simply multiplying. How do I FOIL this out? Again, this is something that if you remember how to do this, you can watch, but if you need to do some work, do some work. X times x is x squared. That's my first. My outer, x times 4 is 4x. Inner, negative 2 times x is negative 2x. Last, negative 2 times 4 is negative 8. Combine like terms, x squared plus 2x minus 8. Just remembering how to FOIL, and that's how I FOILed when I had numbers. What happens if I have, when I have different variables in here? What does that look like? Well, I'm going to do this one a little slower. First, x times y is xy. Outer, x times 4 is 4x. Inner, negative 2 times y is negative 2y. And last, negative 2 times 4 is negative 8. Where on this first problem I had my middle terms cancel out or combine to get 2x, none of my terms here are like terms, so I cannot combine anything. So that is my foiling, and that was just to remember how this works. Next step, wrong page. Let's go ahead and multiply this out. Look what I have here. I have a negative 7i and a positive 7i. So when I FOIL this out, move this down because I'm short. No comments on that, Mr. Lovell. Appreciate it. So I'm going to multiply this out. I'm going to go ahead and do my first. 2 times 5 is 10. Outer. 2 times the square root of 7 is 2 square root 7. Inner. Negative square root 7 times 5 is negative 5 square root 7. Last, negative square root 7 times negative square root, times positive square root 7 is negative square root 7 squared. Well, the 10 stays 10. 2 square root 7 minus 5 square root 7 is negative 3 square root 7. Square root 7 squared, the square and the square root cancel. Remember, 2 divided by 2 is 1, so that's 7 comes out. and then I have a negative. So then I need to combine my like terms. My like terms happen to be the 10 and the 7, my constants. 10 minus 7 is 3, minus 3 square root 7. This is a little different. Everything we've done before has always dealt with variables, but now the thing that's being carried around is a square root of 7. Is that okay? Yeah, I handle it the same way. Let's try a different example. Well, what's different about this? I had to check to make sure I knew what was different about this. What's different about this example? Keep hitting the wrong button, excuse me. What's different about this example is this 2 in front. What do I do when I have that 2 in front and I'm multiplying? Well, let's try this again. I'm short. Yes, Mr. Rubio, I'm short. Deal with it. 2 times 5 is 10. Outer 2 times 2 square root 7 is positive 4 square root 7. Negative square root 7 times 5 is negative 5 square root 7. And negative square root 7 times 2 square root 7 is positive 2. Again, it's the square root of 7 squared. The 2 is not squared. There's only one 2 there. It's the square root of 7 that's being squared. So I'm going to combine like terms. I have 10 plus 4 square root 7 minus 5 square root 7 is going to be minus 1 square root 7 plus 2 times, again, the square root of 7 squared is just 7. Excuse me, that was a mistake. So that's times 7. So this is 10 minus the square root of 7 plus 14. 10 plus 14 is 24 minus the square root of 7. That's how I multiply using square roots. And when a square root is multiplied by the same square root, I'm able to take it out. And again, this is what my answer is. I always put my integer and then my square root after that. Let's try my next example. As I have hidden up here, I want you to note that these are conjugates. Remember what conjugates are. My conjugates mean that my two binomials are identical. The only difference is one is minus and one is plus. So when I multiply this out, hopefully a special thing will happen. Let's see. First, 5 times 5 is 25. Outer, 5 times the square root of 7 is a positive 5 square root 7. Inner, negative square root 7 times 5 is negative 5 square root 7. Last, negative square root 7 times square root 7 is minus square root 7 squared. As in all conjugates, when I did complex conjugates and any other conjugates, my middle terms cancel. 5 square root 7 minus 5 square root 7 is 0. So I get 25 minus the square root of 7 squared. Again, remember the square root of 7 squared, the square and the square root cancel, and that leaves minus 7. 25 minus 7 gives me a lovely 18 as my answer. What's nice about this is in my final answer, I no longer have a square root. I just have a number. That's going to come in handy to that example 7 I had looked at the very beginning of this. So let's kind of continue. Well, let's talk to this one more time. When I did my complex conjugates, I FOILed it out. My middle terms cancel. Then my outer terms, because of the square and the square root, I was able to combine those and get one number without a square root in it. That's awesome. Let's see what else we have. Okay, was that the right one? Did I go too far? Yeah, that's the right one. Well, let's look at this. 8 minus the square root of 2 squared. Is this a complex conjugate? Will this work? Excuse me, not a complex conjugate. Is this a conjugate? Will this also get rid of my square root when I multiply it out? Let's see. Remember, 8 minus the square root of 2 quantity squared means 8 minus the square root of 2 times 8 minus the square root of 2. So I first want to do my first and get 64. Outer, I get negative 8 square root 2. Inner, I get negative 8 square root 2. And last, negative times negative is positive square root of 2. Again, quantity squared. My 64 stays the same. My two middle terms are actually identical, so they don't cancel each other out. They actually combine and double, so I get negative 16 square root of 2. Remember, when I add two radicals, the radical stays the same. I just add the numbers in front. Square root of 2 squared is just 2. Combine like terms, 64 plus 2 is 66 minus 16 square root 2. Unlike the complex conjugates, unlike the conjugates, I have a square root of 2 still in my answer, so it didn't cancel out, but this is how I FOIL out something squared. Let's see our next example. Let's remember how I cleared or rationalized my denominator. When I had a radical, a square root sign in my denominator, I had to multiply by the square root of 6 to get the square root of 36, which was then just 6. I canceled out that radical, so I had a whole number. What I did to the denominator, I had to do to the top, the numerator. 1 times the square root of 6 is the square root of 6, and that just carries on through. And that's what my final answer looks like without a square root in the denominator. Fantastic. Let's see what we can do with this now. Let's do a couple of these examples. 4 plus the square root of 3 divided by 1 minus the square root of 3. I want to get that square root of 3 out of my denominator. If I just, do not copy this down, multiply by the square root of 3, it's not going to work, because if I was to distribute the square root of 3 in here, I would get the square root of 3 minus 3 in my denominator, and there's still a square root of 3 there. So I have to do something different. That thing that I'm going to do different is I'm going to use my conjugate. So instead of multiplying by the square root of 3, I'm going to multiply by 1 plus the square root of 3. It's the identical as my denominator. The only difference is one is negative, the other is positive. What I do on the bottom, I have to do on the top. In my denominator, when I multiply this out, 1 times 1, my first is 1. My outer is positive square root 3. My inner is negative square root 3. My last is negative square root 3 squared. Okay. Again, because they're conjugates, my center terms cancel out. So I get 1 minus the square root of 3 squared. The square and the square root cancel, so it's 1 minus 3. Ooh, let me leave a little more space. This is 1 minus 3. This is still a denominator. 1 minus 3 is going to be negative 2. And I get a number without a square root. How nice. Well, that was my denominator. What does my numerator look like? Well, my numerator looks like my first is 4 times 1 is 4. Outer is 4 times the square root of 3 is positive 4 square root 3. My inner, square root 3 times 1 is positive 1 square root 3. My last, square root 3 times square root 3 is positive square root of 3 squared. When I multiply this out, my middle terms combine. Let me use a different color. My middle terms combine, so I get 4 plus 5 square root 3. Square root of 3 squared, as we said earlier, is just 3. Combine like terms, 4 plus 3 is 7 plus 5 square root 3. I don't care that there is a square root in the top, the numerator. I care that there's not a square root of 3 in the denominator. And so this is my final answer. One last example. This is the one that I showed you at the very beginning. I have a square root of 5 in the denominator. I want to get rid of it, so I'm going to multiply top and bottom by the conjugate of 2 minus the square root of 5. So this is 2. Let's start that over. Instead of multiplying by the conjugate, let's multiply by the conjugate of 2 minus 3 square root of 5. The conjugate is plus, so 2 plus 3 square root 5. What I do on the bottom, I need to do on the top. 2 plus 3 square root 5. So again, I like to do the denominators first so I make sure I get a whole number. Then I can come back and do my numerators. So I'm going to have in here, first, 2 times 2 is 4. Outer, 2 times 3 square root 5 is 6 square root 5. Inner, negative 3 square root 5 times 2 is negative 6 square root 5. And my last, negative 3 square root 5 times 3 square root 5 is negative 3 times 3 is, well, I'm going to write this as 3 square root 5 squared, and I'll multiply it out in just a second. Of course, I put that underneath my radical sign when it needed to be, I put it above it when it needs to be below it. I'm going to redo all of that. Forgive me. So one more time. The first was 4. The outer was 6 square root 5. The inner was negative 6 square root 5. The last was negative 3 square root 5. All of that squared. So again, in my denominator, as I just saw, my 6 square root 5 negative 6 square root 5 always cancels. 3 squared is 9. The square root of 5 squared is 5. 9, see, so I distribute that 2 in. So 9 times 5 is 45. My 4 is still the same. This is 4 minus 45. So I get negative 41. I don't have a square root down there. I don't want a square root down there. That's what it needs to look like. Let's try the numerator. I really don't care what the numerator looks like. I just have to FOIL it out. My first, 2 times 3 is 6. Outer, 3 times 3 square root 5 is positive 9 square root 5. Inner, 2 square root 7 times 2 is positive 4 square root 7. And last, 2 square root 7 times 3 square root 5 is positive 6 square root. 7 times 5 is 35. Combine like terms. Well, let's see. I have a 6. I have a square root 5. I have a square root 7 and a square root 35. None of those are alike. So this is going to be identical. 6 plus 9 square root 5 plus 4 square root 7 plus 6 square root 35. And again, in my final answer, that can't change either. So I'm just going to put that down here. It's an ugly answer. It doesn't look pretty in the numerator. But what we're worried about is my denominator. And my denominator is clearly an integer. There is no whole numbers. So this is my answer. 6 plus 9 square root 5 plus 4 square root 7 plus 6 square root 5. All of that over negative 41. Have a great rest of your weekend. I will see you on Monday.